right, good morning, y'all. Today is the 14th, Monday the 14th. If you haven't already, please put your first and last name at the top of your packet. 3/14/22. This week, these are the assignments that are due this week. You have your warm-up. You have a retest on Friday of the last unit. Your digital interactive notebook is due Friday. And all makeup work. Okay. We have tutoring. If you need help with the retest, tutoring is tomorrow, Tuesday, virtually at 3 p.m. Okay. Today, we're going to do the warm-up. Then afterwards, we're going to do an intro to cluster 6. I'm going to start with real number system. We're going to classify numbers using the real number system. Your homework for tonight is makeup work. You need to work on makeup work. And you need to take pictures to put in your digital interactive notebook. Okay. I'm going to pause to give you a chance to write and then take out your planner so we can write our agenda for the week. All right, let's look at our planner. And then we're going to prepare ourselves to go to the restroom, okay? Monday, I'm going to be checking your planners. This is week, what, last week? It was week 7. So we're doing a new page. This is week 7. This is week 8. All right, so we have March the 14th through the 18th. And this is Q3W8. And I'm going to check your planner on Monday, okay? Monday or Tuesday of next week. Monday's date is 3/14. Tuesday is 3/15. Wednesday is 3/16. Thursday, 3/17. Friday, 3/18. That's when all makeup work is due. Okay. Anything that you're missing, you need to make sure you get it in and complete it by Friday at 11:59. You can put Saturday's dates down, which is the 19th, and Sunday, which is the 20th. Okay. The end of the quarter is next week, the 24th. Okay, that's the end of the quarter. That's next week, the 24th. That's Thursday. And we're out Friday. Okay, it's a teacher work day. All right, so tonight, Math 8 homework is just to work on makeup work. All work that's missing. And you need to take pictures and put in your digital interactive notebook. The abbreviation for interactive notebook, Ymca. And you need to upload those just like we've been doing. Tomorrow's homework will be the exact same. Oh, you're so funny. Take pics again. And we're going to put that also we have our tutoring tomorrow. So it's Math 8 virtual tutoring, okay? And tutoring is at 3 p.m. Do not forget that Friday we have our retest. Math 8 retest. Interactive notebook is due. And then all makeup work is due. Yes. We go as a class, babe. Any questions? I'm going to pause for the calls. All right, so let's look at the warm-up. Let's look at the warm-up. All right, it says Planet Fitness. Shh. Y'all ready? Planet Fitness has a $1 initiation fee. Okay, so you automatically have to just pay the $1, and it has $10 a month. Okay, so you have to pay the $10. That's like the startup fee, and then it's $10 for every single month. So that's your rate of change. So your starting amount B is 1. You automatically have to pay the $1. Yes. I don't think he's not going anymore. The M, thank you for reminding me. The M is $10. Okay, so the equation here for this one, when we write it, is slope intercept form, which is y equals mx plus b. How do we write the equation here? Yes. Y equals 10x plus 1. Very good. All right, and a 35 a month fee, write the two equations. So look, so this one is this is the first equation. The second equation is that the YMCA, so we're comparing to the YMCA has an initiation fee of $70. So this time your starting amount is $70. And then a $35 monthly fee, so you pay that every month. So your slope is going to be 35 for every month. X represents the number of months. Y represents the total. Okay, so the total for Planet Fitness is going to be Y is equal to, that's the total, Y represents the total, is going to be $10 times X. X represents the number of months, plus automatically have to pay $1. The YMCA, on the other hand, the total Y represents the total, is equal to $35 a month. X represents the number of months, plus you automatically have to pay $70. Okay? And the YMCA is much more expensive than Planet Fitness. You can do more at the YMCA than you can do at Planet Fitness. All right? Any questions about that? Okay, let's look at number 2. From the previous problem, determine the cost of the gym, the cost more for 12-month membership, and by how much. Okay, so we need to figure out what it's going to be for 12 months for each, and then how much more expensive is the other one. So we're going to subtract the totals. All right, so let's find the totals for 12 months first. So we have to substitute 12 for each equation to figure out what the total amount is. So let's do Planet Fitness first. 12 months, so that's 10 times 12 months plus $1. So let's type that in our calculator. $10 per month, so that's 10 times 12. Plus, you automatically have to pay the $1. Type that in. What do you get for 12 months? How much is that going to be? Type that in, Kaylee. Type that in, babe.
121.
Very good. $121 for 12 months. Did you see it?
Math one, get me to go to.
Yeah, no, thank you so much. All right, so let's do YMCA, okay? For 12 months. So we got $35 times 12 plus 70. Let's see how much that is. $35 for every month, so that's times 12 is 12 months. Plus you automatically have to pay the $70. How much money is that going to be for the year? All right. YMCA is much more expensive. We want to know how much more expensive is it. So let's subtract to figure out how much more expensive. So we got the $490 minus, and we put the amounts in here. That's okay. We're not going to worry about that part. $490 minus the $121. So type that in. What's $490? Very good, babe. Okay, 190. Oh, I said 190. Sorry, y'all. Minus 121. And it's $369 more for the YMCA. Okay. So the YMCA costs $369 more per month. Okay. All right, I'll pause, give you a chance to write. All right, any questions? Remember, tonight you're working on makeup work. Okay, so any place where you have a 0 in Canvas, you need to go back in and you need to resubmit or submit those assignments, okay? That's what you're working on tonight. You need to finish it and submit. All of your packets should be in your folder. Yes. What does it say right there? This right here.
Also, if you have a low score on one, submit it.
So any low grades, if you don't like your grade, Amanda, sit up, babe. If you don't like your grade in something, can you tap her for me? If you don't like your grade in something, then you can go back, just like Miss Moore said, you can go back and do it again and resubmit. Tater, sit up.
Quizzes also, if you have other attempts on those, you can I'd look through your old packets and review videos on what you need to review, and you can also review those. If you feel like any of that doesn't need to be done, I-ready projects. We have another one coming to do soon, don't we, Ms. Reyes?
No, we don't. We just had that one this quarter. All right, so
still resubmit for that?
Yes, I did tell you all that a bunch of times to go ahead and get those things in. All right, take out your notebook. Take out your notebook. We are on page 18. We are on page 18. This is Q3, page 18. And this is Intro to Cluster 6. Oh, I have any more. All right, we're going to pace down. Please share glue with the person that's near you. You share here. Share there. Share here. Share there. Amanda, sit up, please. Sorry, baby. Oh, it's rolling. It's rolling. All right, so paste this down. Looks just like this. Cluster number 6, reasoning. This is page 18. All right, so this is page 18. We kind of started this last week. We went over how to change, how to convert a fraction to a decimal and all of those things. That's included in this unit, okay? So we're a little bit behind in scheduling, but not much. Okay, and so this is week by week what you'll see. This is a very short unit. We may have to extend it into fourth quarter by a couple days, but it shouldn't be more than a couple days, and we'll make it into a quiz or a test, but it will not be that long because this is a very short unit. Okay. All right. There's a sheet that I gave you. It looks like this. At the top it says real number system. It looks exactly like this. Please take that out, put that in front of you. You can push this to the side. We are going to do page, I'm going to go ahead and write this in. We are going to do page 19, which is the real number system. Okay, we're going to do that. No, oh, that one, yes. The top, that cover sheet. And then page 20 is going to be classifying numbers. This is page 20. And we're going to say classifying real numbers. And this is going to be the end where we're going to stop our interactive notebook for quarter 3, okay? This is page 20. Okay. The classifying number sheet, I'm going to go ahead and pass that out so you can paste that down. And we're going to do that afterwards. While you have a blue stick, go ahead and do that. This is page 20. Please paste this down on page 20. This little half sheet, I want you to paste down on page 20. It looks just like this. This is going to be on page 20. Go ahead and paste that down. This sheet right here, don't paste this down yet because we want to write on it. And it's hard to write on it when you paste it in the notebook and so big. This is page 20. Please go ahead and glue that down. Share your blue stick with the person that's beside you or that's around you. You got this over. Please paste down page 20. This is page 20. Please glue this. Glue this on page 20. Thank you, Ms. Glue this on page 20. Yes. Oh, I wanted y'all to pass it around. But I said I'll turn it. Yeah, there you go.
Do you need more glue sticks?
Yes. Did you glue this down? Did you glue it down? Anybody else need a glue stick? give you one of these. Where's your notebook? Take your notebook. All right, got it? Okay, this is what you should have on your desk at this time. We're going to go through the real number system. I'm going to give you the definitions and stuff first, and then we're going to put it in a chart. We're going to fold this in half after we're done, and we're going to paste this on page 19. Okay, so we're going to do this side first because we need the definitions. Okay, definitions and examples we're going to do first. All right, so I'm going to put, this is a real number system. This is a real number system. Real numbers, I'm going to put the definition for real numbers on the bottom. All right, so with real numbers are any and every number you can think of. Any and every number. Any and every number you can think of. Any and every number. Real numbers are any and every number. Fractions, decimals, whole numbers, square roots, perfect square roots, repeated decimals, non-repeated decimals. Any number you can think of is going to be a real number. Any and every number is a real number. Write this down. Maddie, write this down. Any and every number. Any and every number. Fractions, decimals, mixed numbers, whole numbers, counting numbers, perfect square roots, non-perfect square roots, terminating decimals, repeated decimals, pi. Any and every number is going to be a real number. Any and every number. Real numbers are divided into two different subsets, two different groups. Either a number is rational or it's real or it's irrational. Okay, so a real number is broken into two groups. Either it's going to be a rational number or it's going to be an irrational number. Okay, a real number is either one or the other. It cannot be both. A number can't both be rational and irrational. Kylie, sit up, babe. Rational or irrational. Cannot be both. It's either rational or it's irrational. A real number is any and every number. A real number, any and every number. Real numbers are broken into two different groups or subsets. It's either going to be rational or irrational. It cannot be both. A real number is any and every number. A real number is any and every number. Either a real number is going to be rational or irrational. It cannot be both. It's either one or the other. It's either rational or it's not rational. Well, what is a rational number? Rational numbers are numbers that can be written as a fraction. Numbers that can be written as a fraction. Numbers that can be written as a fraction. Where irrational numbers, meaning not, numbers that cannot be written as a fraction. So rational numbers are numbers that can be written as a fraction. Irrational numbers are numbers that cannot be written as a fraction. Bless you. Meaning not. This prefix means not. That's not. It's not rational. Rational, numbers that can be written as a fraction. Irrational, numbers that cannot be written as a fraction. All of which are real numbers. Every number you can think of is a real number. So they're both real numbers, but one you can write as a fraction and the other one you cannot write as a fraction. Examples. Okay. Let's do irrational first. That list is much shorter. Okay. Non-perfect roots. That means roots that are not, that when you type them in or when you simplify them, they're fractions. So, I mean, they're decimals. So the square root of 22, if I type in the square root of 22, it's going to be a decimal. Square root 22. See? It's a decimal. Okay? That's irrational. Square root 7. It's a decimal. It's irrational. The square root of 6 is irrational. It's a decimal. The square root, any square root that when you simplify it, it's a decimal, it's irrational. 91, irrational. Okay? Those are all irrational. So we got square root of 22 is irrational. The square root of 15 is irrational. The square root of 51. All of these are irrational. And there's so many more. Okay? The other is pi. Okay? Pi is a non-terminating decimal that repeats, but it doesn't have a pattern to how it repeats. So it is irrational. It keeps going on and on and on, and there's no pattern as to how pi is going to repeat. So since there's no pattern for that, it is irrational.
And today is National Pie Day.
Oh, it is, isn't it? All right. Next. Pi day. All right. What's the other one? And the other one is a non-terminating decimal. That means it doesn't stop. These are decimals that repeat, but they don't have a pattern to how they repeat. Okay, so you might have 5.682 ... It repeats, but it doesn't have a pattern as to how it repeats. So you don't see the bar notation or the repeated symbol above any of the numbers. Okay, so you'll see the dots at the end because this is telling you like to be continued. It's going to continue on and on and on, but it doesn't have a pattern to how it repeats. These are irrational. These are the only decimals that are actually irrational. Okay, all other decimals are rational. All right, so examples of rational numbers. That's everything else. That's not these three. So we have, of course, a fraction, 1/2, mixed numbers, 3 1/4. We have decimals, 0.62. It stops, doesn't have the dots at the end. It is rational. Even a repeated decimal, 5 repeating. You know what number is coming next. This is rational. You have whole numbers, 52, negative numbers, -5, 0. These are all rational. You have perfect roots, the square root of 25. When I type in the square root of 25, see what that equals? That's a whole number. There's no decimal here. This is a perfect square root. Okay? This is rational. The square root of 4 is rational. It's 2. It's not a decimal. It's a whole number. Okay, so we got integers, whole numbers, fractions, repeated decimals, regular decimals. All of those numbers can be written as a fraction. That's what makes them rational. So again, a real number is any and every number. A real number is any and every number. Okay? Real numbers are broken into two groups. Either a real number is rational or it's irrational. It cannot be both. Okay? Rational numbers are numbers that can be written as a fraction. Irrational numbers are numbers that cannot be written as a fraction. There are three types of irrational numbers: non-perfect roots, pi, and non-terminating decimals, the decimals that have the ... at the end. They continue without a pattern. Okay? Next we're going to talk about is integers. That's the next subgroup. Integers are rational numbers, okay? They are rational, okay? They're real numbers and they're rational numbers. They are real and they're rational as well. The definition for a real number are whole numbers and their opposites. Whole numbers and their opposites. Whole numbers and their opposites. They don't have fractions, no decimals attached. No fractions, no decimals attached. Okay? Examples of what that looks like. We have -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, all the way to the positive infinity. And this is going to keep going on to the negative infinity. The infinity sign is a sideways 8. So it continues in this direction and the other direction as well, as long as they do not have fractions or decimals attached. No fractions, no decimals attached. It could be positive numbers, negative numbers, and 0. Remember, 0 is neutral, but 0 is an integer. 0 is also rational. 0 is also a real number because any and every number is a real number. So an integer is rational. Rational and irrational are real numbers. Every number is a real number. So rational numbers are real numbers. Irrational numbers are real numbers. Integers are real numbers. The next subgroup that we're going to talk about are whole numbers. Whole numbers do not have fractions or decimals attached to them. Okay? And they are not negative. Okay? They are not negative. Whole numbers start at 0 to the positive infinity. Okay? Infinity is the sideways 8. No fractions. Oops, sorry, y'all. No decimals. Examples. Starts at 0. Is 0. 1, 2, 3, 4, 5, 6, 7, all the way to the positive infinity. It never ends. They do not have fractions attached to it. They do not have decimals attached to them. No fractions, no decimals. No fractions, no decimals. No fractions, no decimals. A whole number is a rational number and it's a real number. Any and every number is a real number. So rational numbers are real numbers. Irrational numbers are real numbers. Integers are real numbers. Whole numbers are real numbers. Now we got natural numbers. These are the first numbers that you learn when you're introduced to mathematics. Natural numbers. Your natural numbers are your counting numbers. No fractions, no decimals. No fractions, no decimals. When you start learning how to count, you start with what number? 1. So we start with 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and so forth to the positive infinity. It goes on forever. They do not have fractions attached to it. They do not have decimals attached to it. The only difference from a whole number and a natural number is 0. Natural numbers do not include zeros. Natural numbers start at 1. Whole numbers start at 0. That's the only difference between these two. Whole number starts at 0. Natural number, counting numbers start at 1. And all of these numbers are examples of real numbers. Rational is a real number. Irrational is a real number. Integer is a real number. A whole number is a real number. A natural number is a real number. Any questions? Anybody still copying? Nobody? Okay. Oh, okay. Let me pause. All right, here we go. All right, good folks. Turn the paper sideways like this. So now we're going to focus on this part. We're going to put all the information into a graphic organizer so that it can kind of make more sense, hopefully. Okay. All right. So again, every number is a real number. That's why you see this big rectangle, because every single number you can think of is going to be a real number. Rational numbers are real numbers. Irrational numbers are real numbers. Okay. So rational numbers are numbers that can be written as a fraction. Abbreviate, can be written as fraction. Irrational cannot be written as fraction. Sure.
Soccer practice is canceled this afternoon.
Okay.
Soccer practice is canceled today.
Cool beans. There are 3 types of irrational numbers. What are the different irrational numbers? Come on. I told you what they were. What are they?
Rational or irrational?
Irrational is where we at right now, babe. Non-perfect roots. Non-terminating decimals. We got non-perfect roots. And pi. Very good. Somebody said non-terminating decimals. And pi. Okay. Give me an example of a non-perfect root. What's an example of a non-perfect root? Yes. Non-terminating decimals. Square root of 22. I gave you that example already. Can you give me another one? That is correct, though. What's another example of a non-perfect root? Leah, sit up, babe. Square root of 5. What else? Bless you. There are so many. Square root of 8. Perfect. Square root. Somebody already said that one. Square root of 9. Type that in. What's the square root of 9? Come on. What's the square root of 9? What number can be multiplied times itself to give you 9? 3. 3 times 3 is 9. That's a perfect square root. Somebody else? What's a non-perfect? We got square root of 8, square root of 5. There's so many. Square root of 86. What was yours? Square root of 15. Yes. Square root of 3. Yes. Well, give me an example of a non-perfect root.
It keeps continuing.
Yeah, but give me a number. Non-perfect root. Square root of what? 4. What's the square root of 4? It's 2. It's a whole number. Yeah, 2 times 2 is 4. So that's rational. Give me another example. Yes. That's 1. 1 times 1 is 1. Yes. 87. Okay. All of these are non-perfect roots. What about terminating decimal? Give me an example of a non-terminating decimal. 6.6 what? 3 ... It repeats and it doesn't have a pattern as to how it repeats. You see those dots on the end. Give me another example of a non-terminating decimal. Come on. Yes. 70.78 dot. Okay. Give me one more, please. Another example of a non-terminating decimal. Notice how these have dots on the end. So that means we don't know how they're repeating. Yes.
I have a question.
Yep.
Is that the 70 and 78? Is that like its own thing?
This is a decimal.
Okay.
Yes.
40.45 dot.
45 point what? 5.
5.
Let's do 782 dot. Okay. All right. And then pi itself. These are all examples of irrational numbers. Okay. All right. So let's think about what's rational. That's whatever this is not, it's going to be rational. A fraction itself, if we have the fraction 3/4, it's a fraction. That is rational. Okay. A repeated decimal, 0.5 repeating, 0.62 repeating. Those are rational. Okay. Perfect square roots are rational. Give me an example of a perfect square root. Somebody said one earlier, the square root of 4. How do we know? Look, 2 times 2 is 4. The square root of 4 is equal to a whole number 2. That's a perfect square root. It's rational. These were irrational because they were decimals. Give me another example of a perfect square root. Yes. The square root of 1. No, the square root of 6, when you type that in, the square root of 6 is a decimal. That's irrational. Okay? Give me another. The square root of 9. When I type in the square root of 9, that gives me 3 because 3 times 3 is 9. What one number can be multiplied times itself to give me 9? Well, 3 can. So the square root of 9 is 3. Give me another example of a perfect square root. Yeah. The square root of what? 1,000. If I type in the square root of 1,000, what does that give me? See? So that's that's irrational. Put that over here. Okay? That's a good try though. Yes. The square root of 25. Yep. That's a perfect square root. It's 5. Good job. Anybody else? Yes. The square root of 10. When I type in the square root of 10, what does that give me? What number can be multiplied times itself to give me 10? 5 times 5 is 25. It's not one. You see? That's irrational. Square root of 10. Do you see that? Okay. Yes. The square root of 16. Yes. The square root of 16 is what? What number can be multiplied times it? 4. 4. All right. So those are that. Even mixed numbers. 3 and 1/4. Okay. What did I miss? Did I miss anything? Negative numbers. A negative 6. 0. All of those are rational. Integers. Okay. So my integers are no fractions, no decimals. So we could have 0. We could have even we could put the square root of 25 because what's the square root of 25 equal to? 5, which is a integer. The square root of 16 is an integer because what's the square root of 16? No, 4. 8 times 8 is 64. Okay. So you don't want to put that down. All right. So we got positive 3, negative 6. Positive, negative numbers, as long as they don't have fractions or decimals attached. Positive numbers, negative numbers, and 0. No fractions, no decimals. Whole numbers. Whole number can be 0 also. Could be 5. It could be the square root of 16 because that's equal to 4. Okay. It could be 17. Could be 100. All of these are whole numbers. No fractions, no decimals. Natural numbers. A natural number are counting numbers. When we start counting, what number do we start counting with? 1. So it can be 1 to the positive infinity, 2, 3, 4, so on and so forth to the positive infinity. No fractions, no decimals. Any questions? Do you see what box a natural number is? The natural number box is inside of a whole number. So natural numbers are whole numbers. The natural box is inside of the integer box. The natural box is inside of the rational box. So a natural number is a whole number, it's an integer, and it's rational. A whole number is inside the integer box and the rational box. Any questions about that? I'm on diet. I know. Oh, you're so sweet. All right, any questions? This is page 19. Please paste this in page 19 and pass the glue sticks up to the front. Please take the time to paste it. Pass the glue sticks up to the front. Please put your calculators back, please.